So welcome to the class and in continuation with Unit 5. In this I'm going to do one question as to what would be the consumer's equilibrium given an indifference map and the budget line. And I'm sure you got it. With the indifference curve that is tangent to the budget line, that would be the consumer's equilibrium with Hickson analysis. In other words, where the marginal rate of substitution is equal to market rate of exchange. So, and there's only one point, and why not? Like, why shouldn't there be consumers equilibrium at F and G? So, let's just do this. So we see that there is an indifference map of indifference curve 1, 2 and 3. And we have this budget line which is AB, and tangent to that we have IC2, indifference curve 2, where the indifference curve is convex to the origin, and that is the point where it is tangent to the budget line at E. So it is here that the MRS, that is a marginal rate of substitution, equals to the market rate of exchange, that is a ratio of prices. The market rate of exchange is Px upon Py. And what is marginal rate of substitution? It is how much does this consumer give up Y commodity for X commodity. So in the figure we see that the budget line AB, and to which the indifference curve that is tangent is indifference curve 2. So here MRS is equal to MRE, that is market rate of exchange, that is Px upon Py, or MRS is what? Change in Y upon change in X. What is change in Y? That is how much of good Y you are ready to give up for getting one more unit of good X. So you see that the slope of indifference curve is equal to the slope of the budget line, and the two slopes are equal where the budget line is tangent to the indifference curve IC2. So the tangency condition is fulfilled at E. This is consumer's equilibrium. The highest the consumer can reach is the utility level indicated by the indifference curve 2. The utility maximizing, that is optimum combination of the two goods, is OX1 of good X and OY1 of the Y good. Now the consumer can afford all the combinations on the budget line AB. Then why does he choose E only? What is wrong with the combination F or combination G? The wrong is that both the combination lie on a lower indifference curve IC1, as we can see that, which means lower utility. Why should the consumer choose a lower utility level IC1 when he is conveniently getting a higher utility level at IC2, especially when both cost him the same? Now we can generalize like the points F and G. Every other point to the left of E or to the right of E on the budget line will lie on a lower indifference curve. That is, will have lower utility level as compared to the tangency point E. Therefore, the consumer will choose only the tangency point on the budget line. Now the question is, you can see the IC curve 3 also. Do you think can he reach this IC3, a high utility level? Well, the answer is no, because his income and the market prices do not permit him to go beyond indifference curve 2. So the consumer cannot afford indifference curve 3. They are unattainable combinations. It's an unattainable, beyond his budget. It's beyond the budget constraint. Now, can the consumer choose a point below the budget line? No, because this violates the assumption that the consumer must spend the whole of the income. And there is another reason too. Any combination below the budget line will lie on a lower indifference curve which means low utility level. The consumer must choose a combination that lies on the budget line. And well, we have a second condition too. So the first condition we finish, MRS is equal to MRE. And the second condition is that the MRS continuously falls. Now this is according to the law of diminishing marginal utility. The condition ensures that if the marginal rate of substitution is not equal to market rate of exchange, the falling marginal rate of substitution will lead to equality again, as explained in the first condition. Graphically, the condition means that the indifference curve is strictly convex, that is to the origin, and it is tangent at that point to the budget line. So this is the only equilibrium point, as you can see. Isn't it interesting? I mean, this is one question that you can get and you should be able to answer.